Hi all, I'm Lesley, and today I'm here to talk about making impossible state unrepresentable. So considering a scenario where you're trying to track a bug in your code base, and you fire a debugger, and then you inspect the states of your program, and then you bang your head with, how is that even possible? And sound familiar? So if that is the case, then you may say, unit tests can help. I agree, unit test is great, but I will assert that test is great, but unrepresentable is better. So my motivation comes from the following snippet of code that I copied from a tutorial website. And clearly, a lot of people are copying this particular piece of code without modification into their code base. And in here, we have a bunch of Q indices. And we need to query them and then use them later. And we query the indices by loops through all the queues. If they satisfy certain criteria, then we just store them. This function is the only place we ever have uninitialized queue indices. So why not just model our structure like this? And then we can only use stud optional of Q indices as implementation details. Note the memory footprint get reduced. In the first implementation, we have 24 bytes for the structure of the Q family indices, partially because of the inefficient alignment of multiple stud optionals. And the second implementation only have 12. There are also less assertion and runtime checks. Because just think about the first example, we have isComplete function, and in the second example, it totally goes away. Because we never need to call this logic twice. API also become cleaner if we utilize the type system better. For example, here is another example. Using stud variant. It's a computer graphics example. For people who are familiar with graphics programming, this example is really contrived, but it kind of have the point. We have multiple commands that we need to send into GPU. And first, we catch them in a buffer and later submit them. The problem here is that the graphics pipeline object is what encapsulates all the logic of how to draw objects on the screen. However, we can happily start to draw without binding any graphics pipeline. So an easy fix is to put graphics pipeline into the draw command. However, we do pay an overhead here because rebind graphics pipeline is costly operation on GPU, so we don't want to do that. So instead, we may have some logic to check the graphics pipeline is still the same when we do push command. So going a bit further, we can introduce a second structure called secondary command buffer that has one pipeline and a vector of command. This way, we don't have overhead. We don't need to sort against usage of graphics pipelines, and it's really easy to build secondary command buffer in parallel. Before the end, I want to talk the pitfall of move semantics. We all love move semantics, at least I love them, but it do open a hole in our type system. So in CppCon 03, we can have a perfect RAI class to represent resource handle. But we cannot move them, so in CppCon 11, we introduced move semantics. Now we can move them. But then our resource handle become a pointer-like object because an after-move object must be valid and unspecified. Unspecified doesn't matter because we specify what the class is doing, but to be a valid after-move state, the only thing that we really can do for a resource handle is nothing. So we are forced to represent the empty state. And so my suggestion is move semantics is nice, but if you can get away with it, then just delete the move operations. And in CppCon 17, you can even rely on the mandatory copy deletion. Thank you.